Good afternoon, guys. Now we have just explained you what actually the capacitor is. Here, in this case, just I have elaborated in detail the parallel plate capacitor. Actually, this is the plate 1 and this is the plate 2. Just I have indicated these are the conducting plates. Conducting plates. Conducting plates. These two, and this is a dielectric medium. It is nothing but a insulation. It may be this insulation may be paper insulation, this may be mica, this may be just air, or this may be ceramic, or this may be plastic. And electrolytic capacitor is charge controlled capacitor. You can see where the positive and negative signs will be appeared. Now, as per the insulation, we have distinguished it as paper, mica, air, ceramic, plastic, you can say. And from figure you can distinguish the two plates are separated by a dielectric medium, where the terminal A and B is been isolated by the dielectric medium. The dielectric medium is nothing but a insulation, where the capacitor gets, means these two plates gets discharged, means separated, and when you apply a voltage source across that capacitor, slowly the current will flow through it, and as the time permitted or time lasts, the charges will be accumulated on the one either sides of plates, positive charges and negative charges, and accordingly the electric field will be set up, and in type of that electric field the voltage will be stored in capacitor in form of electric field. That's why we have said that. And as you say, or as you see in the circuit actually, or a diagram, the C is equal to epsilon A by D. Epsilon is nothing but a permittivity of that material which are using, means we are using that dielectric material. It may be paper, mica, air, you can say. This epsilon 0 is nothing but permittivity of space in if it is air, epsilon A for that air, it will be 8.854 into 10 raised to minus 12 farad per meter. Here capacitor will be, its unit will be farad, you can say. Or simply you can say coulomb per volt farad. This is nothing but the unit of capacitor. Here the epsilon is the permittivity of the dielectric medium, A is the area, and D is the distance in between two plates. Accordingly you will calculate the capacitor. When such kind of numerical will also be asked in exam in order to calculate the capacitance. And even the energy which is stored here, will be given by simply E equal to half CV square. C is nothing but the C is nothing but the capacitance, V is the voltage which is been applied, and this is the energy which will be given in joules. You can say joules. Half CV square, it is nothing but the energy which is stored in this capacitor. And epsilon r is the relative permittivity. Actually, this final epsilon will be calculated as epsilon r into epsilon 0. Epsilon 0's value is already 8.854 into 10 raised to minus 12. It is constant, and this value epsilon r, it will vary as per your medium, which kind of medium you are using. You are using air, mica, paper. Each and every has variable values of this epsilon r, and accordingly you will calculate this epsilon. And this capacitor charging and discharging process we will be dealing in next lecture, because sometimes you will found it difficult to interpret all these things. That's why I have given you in nutshell what actually the capacitor is, how its working is. Now in next lecture we will be dealing with charging and discharging of capacitor. Simply in nutshell I will explain you one thing is tau. Tau is equal to R into C for this kind of RC circuit. R is nothing but resistor, this is the capacitor, this is the voltage which is applied across it, and some form of current flows through it. For this RC circuit, this is the tau equal to RC. Tau is nothing but a time constant to charge or discharge a capacitor. Some sort of time will be required. That time will be calculated by multiplication of R and C. Both are passive elements, resistance and capacitance. For series RC circuit, this is series RC circuit. This time constant I will be explaining in detail in next lecture. Just now I have told you in nutshell. This will be in seconds, because this tau will be in seconds as it is time constant. The time required to charge or discharge a particular capacitor. With the help of this we will calculate when the capacitor will charge to fullest, or when the capacitor will be discharged, or how much time it will take to charge or discharge a capacitor. Thank you for watching eSpark Tech Academy, and please subscribe the channel and like the videos. That will motivate me to explain you or teach you sort of concepts, each and every concepts in very nutshell and in very simple manner. I am teaching you this. As we have seen the capacitor is nothing but a passive element. Passive elements are the elements which does not depend upon the direction of current or direction of flow of supply. It will give you output irrespective of direction of current. And these passive elements, how this works for AC, for DC, I will show you in detail. How the capacitor will react for DC supply, how it will react for AC supply, and how it is useful to you when you go for filter circuits, means how to get the ripple free DC from AC. These things will be also explained you in next lecture. Thank you very much.